This is your review for quiz 6.1 to 6.5. Make sure you have paper out, that you're taking notes, and you're best preparing yourself for your quiz. The first question says to express the ratio of 12 oranges out of 30 fruits as a fraction in simplest form and then explain its meaning. So here it tells us to write the ratio. We know two things about ratios. They have no labels and they're simplified. So we have 12 oranges out of 30 fruits. I'm going to write this as 12 out of 30. Then I need to simplify. I can divide both of these by 6. 12 divided by 6 is 2. 30 divided by 6 is 5. So my ratio is 2 to 5. You could write it like this, 2:5. You could write it 2 to 5. Or you can write it as a fraction like we did at first, and then it says to explain its meaning. So the easiest way to explain a ratio's meaning, I think, is to start with the denominator. I don't know, I always tend to do that. So I write, for every 5 fruits, there are 2 oranges. Okay, so you can always do that. Start with the denominator for every 5 fruits, then go to the numerator. There are 2 oranges. Okay, so make sure with ratios, simplified, no labels. The next problem says to write as a unit rate. So what we know about rates is that, well, especially with a unit rate, we need a 1 on the bottom. And then we need 2 labels, okay? So it's the difference between ratios and rates. Rates, we need 2 labels. So to get this denominator to be 1 hour, I'm going to divide both of these by 5, because that's going to tell us how much money we have in 1 hour. 48 divided by 5. And remember, you can use your calculator. 9.6, but since we're talking money here, I'm going to do $9.60, and I'm going to make sure I have a label because unit rates need 2 labels and a 1 on the bottom. The next question says to tell if the relationship shown in the table is proportional. Explain your answer. So here we're comparing plants and cups of water. We're figuring out if that relationship is proportional. So the easiest way to do this is to divide either bottom by top or top by bottom and keep it consistent. So I'm going to take 3 divided by 2. 3 divided by 2 is 1.5. Then I'm going to take 8 divided by 7. Top divided by bottom, and I get 1.14. Well, here we already have 2 different rates, so not working. We are going to write it is not, and make sure that you know how to explain the meaning. It is not proportional because the rate of plants to water is not constant. Okay, it is not proportional because the rate of plants to water is not constant. Then we have Julia earns $6.50 an hour for babysitting. She earns an extra $2 for each activity she plans and does with the children. Is the amount of money she earns proportional to the number of hours she works? So we know she makes $6.50 an hour. That's constant. So that's proportional there. But then we have this extra amount. Whenever we have an extra added on, it automatically makes it non-proportional because maybe one time she plans an activity, maybe another time she plans 5 activities, maybe another time she plans 0. So it's already not proportional. So we're going to say for our explanation, it is not proportional proportional because she gets an extra $2 only sometimes. Right? If she were to make $6.50 an hour and she planned an activity for every single hour, every single time, then it would be proportional. But that's only the $2 sometimes, so it's not proportional. You could also say our basic sentence, it is not proportional because the rate of hours to money is not constant. Okay, the next question says the grocery store sells 12-ounce bags of M&Ms for $2.89. Is the cost proportional to the number of bags you buy? So you could either write an equation or set up a table. So let's do money and bags. So if I buy one bag of M&Ms, one 12-ounce bag, it's going to be $2.89. If I buy 2 bags of M&Ms, it's going to be $2.89 times 2, which is $5.78. If I buy 3 bags of M&Ms, it's going to be $2.89 times 3, which is $8.67. Then to see if this is proportional, I can take top divided by bottom. Well, 289 divided by 1 is 289. 578 divided by 2 is 289. 867 divided by 3 is 289. So yes, this is proportional. So we can write it is proportional because the rate of money to bags is constant. Okay, we're looking to see if that rate is constant or not. If you did an equation, you could also write this as y equals $2.89 times x. So $2.89 per bag. Remember, whenever we don't have addition or subtraction, it is proportional. If there was addition or subtraction in that equation, it would be non-proportional. All right, couple more left, you guys. This one says, how many miles are in 80 kilometers? If 1 mile equals 1.609 kilometers. So think about the two things that we're working with here, miles and kilometers. So I'm going to set up a proportion, and I want you to do that on your quiz too. I want to see that you know how to set up proportions. We're going to do miles over kilometers. So it says how many miles are in 80 kilometers? So I'm going to do x over 80 kilometers equals, and then I know 1 mile, so I'm going to put that on the top, over 1.609 kilometers. Miles over kilometers equals miles over kilometers. Keeping it consistent. Then what I'm going to do is I'm going to cross multiply. I'm going to take x times 1.609, and I get 1.609x equals, 80 times 1, which is 80. To get x by itself, I'm going to divide both sides by 1.609. And I'm left with x equals 49 we'll round that to the nearest tenth, 49.7, and then make sure we add a label, miles. The next question says you can buy a 12-ounce can of corn for 89 cents. Or you can buy a 20-ounce can for $1.52. Which is the better buy? Explain your answer. So when we compare here, let's get these to both be at a unit rates and figure out how much each can is for 1 ounce. So we always put money on top. So we'll do 89 cents over 12 ounces. And we're going to compare that to $1.52 for 20 ounces. So So I'm going to change this to a unit rate to figure out how much it costs for 1 ounce. So I'm going to divide 89 cents by 12. And rounded, I get about 7 cents per ounce. Okay, then for the 20-ounce can, to get it to be out of 1 ounce, I'm going to divide both by 20. So I'm going to take $1.52 divided by 20, and rounded, that would be 8 cents. So the better buy would be the 12-ounce can. And then it says explain. So all I'm looking for is for you to say, it is cheaper per ounce. That's enough of an explanation for me. Last problem says a recipe calls for 1.5 cups of sugar. How much sugar will you need for 2.5 recipes? Okay, I'm working with fractions here. I'm actually going to change it to decimals because it makes things a little bit easier when we set up proportions. So I'm just going to write this as 1.5 and 2.5. So one recipe calls for 1.5 cups of sugar. So if I do recipe over sugar, I'm going to do one recipe over 1.5 cups of sugar. And I'll do C for cups. And I'm going to set that equal to, it says how much sugar, so that's going to be an X on the bottom, cups of sugar, will you need for 2.5 recipes? So 2.5 R. To solve for X, I am going to cross multiply here. I'm going to take 1.5 times 2.5, and I get 3.75 equals 1 times X is just X, or 1X. So it says, how much sugar will you need? Well, I'm going to convert this back into fraction form since I was given my problem with fractions. So I know 0.75 is 3/4, so it's going to be 3 3/4, and then my label would be cups of sugar.